Hi, thank you very much for giving me the opportunity to give this talk. I'm going to talk about the use of rose Bengal photodynamic therapy as a novel treatment for corneal cross-linking. I don't have any financial disclosures. Thank you very much for all the authors for your all support. So the use of rose Bengal photodynamic therapy has been described for many years. We've mainly been using it for corneal infections. One of the first papers published by our group in 2014 on the use of rose Bengal photodynamic antimicrobial therapy for in vitro studies, showing good antimicrobial effect. And followed by that, it has been several papers, including one of the papers where we showed changes on the cornea, such as demarcation line after rose Bengal photodynamic antimicrobial treatment for corneal infection. One of the recent papers we published where we showed changes on the cornea in rabbit model, where we did OCT anterior segment on the cornea. We found corneal changes such as the demarcation line compared to the control group. This is one of the examples that we treated for corneal infection with acanthamoeba. This is before the treatment, not responding to standard medical treatment, and this is 6 to 8 weeks after rose Bengal photodynamic antimicrobial therapy plus standard medical treatment. You can see the cornea pretty thin compared to previous to treatment. So this is one of the prototypes, green light treatments built by Dr. Perel and his team. Also, another group described the use of rose Bengal cross-linking is Dr. Koshibar, which uses a 100 joule centimeter square green light power and as well 150 joule centimeter square, showing increased corneal stiffness compared to control group. So the purpose of this study evaluated elasticity of the corneal tissue after using two different protocols using atomic force microscopy through microindentation. So the protocol that we use is basically where we start with depithelializing the corneal surface, followed by applying a sponge, 8 millimeter sponge, where we saturate with rose Bengal, and we put it on the surface of the cornea. And then we put 3 drops every 3 minutes for 30 minutes, followed by removing the sponge and rinsing with the saline solution, and then applying the green light treatment for 15 minutes. So in this experiment, we use a whole gloves, a total of 27 pairs. The right eye was a treated eye. We previously, these gloves, we put it in overnight with 20% of dextrant to on a 4 degrees Celsius, so we can maintain the physiological corneal thickness. Followed by the treatment that I described before, and we have 2 groups, one from 6 milliwatts per centimeter square, the low intensity group, and the high intensity group with 12 milliwatts. So the atomic force microscopy has been commonly used for high resolution imagings on surfaces of topography, but also can measure the mechanical properties via nano indentation using a cantilever. So this basically pushes on the sample and measures the resistance, and also measures using the Hertz module as a standard method to determine the Young modules of elasticity to be recorded. So Dr. Sienberg and her group built this customized machine, used it in different type of different tissues on an eye model. In this study, we cut with a microkeraton, 50 microns, measuring the anterior stroma, and 200 microns measuring the mid stroma. So in our results, in the low intensity group, we did not find any difference on elasticity on the anterior stroma and as well on the mid stroma comparing to the control groups. But on the high intensity group, there was some difference on the anterior stroma, but not in the mid stroma. So we find difference between the treatment group and the control group only on the anterior stroma on the high intensity group. Doing more analysis on these between these groups, we obtained and quantified the stiffening effect on the anterior stroma by dividing the treated group divided by the untreated group, and we found a higher stiffening effect on the high intensity group compared to the low intensity group. So on an average, the stiffening effect of the intensity on the low intensity group was 1, which indicates no difference between the treated and the control group. And the high intensity group had a stiffening effect of about 1.3 average, which indicated the treatment increases stiffness of the cornea. What does this mean, the stiffening effect? So what we did is compare our protocol study with rose Bengal treatment compared to riboflavin protocol using the Pedersen protocol. There was a previous study that it was done with the exact same protocol and the same machine, where we can see on this graph the riboflavin cross-linking had a higher stiffening effect than the rose Bengal treatment, even in the low intensity group, and as well on the high intensity group on the anterior stroma. So in conclusion, the effect of rose Bengal cross-linking seems to be limited to the anterior corneal stroma and does not extend to the deeper stromal region. And the high intensity group had a stiffer anterior corneal stroma when compared to the low intensity group. Thank you very much.